share my whole screen. And please let me know if you can see it before I start.
Yes, we see your presentation.
Great. Okay, so I think we can start. So first of all, before we jump into the presentation content, I would like to say that I'm really excited to be here, and thank you so much for this opportunity to present this session. With reference to the content, the source code of the project that we are going to talk about today is available on my GitHub. At the top of this presentation, you can see the link to my GitHub profile. The project is called Call Center Talks Analysis. And you will find the whole source code we will discuss during today's meeting. And also, with reference to the content of this presentation, I always trying to approach this in this way that first of all, we will talk about more theoretical content about some technical aspects, but from the theoretical perspective. And then we will jump into the source code just to make sure that once we understand what is happening when talking about the project and solution implementation, we can then discuss the source code, what is happening in the source code, what are the implementation details. And at the end, if you have any questions, I'm more than happy to answer them. So please post them on the chat. And after my presentation, I will do my best to answer them. Okay, so today's presentation is called Call Center Talks Analyzer built with the Azure Cloud. So today we are going to talk about different services connected together to build an analyzer for different kind of conversations that were recorded in the call center. And one note here, this is the small proof of concept that we did together with one of our customers. I will talk about this more later, but this is a real project. I tried to share as much code as I can on GitHub. So today I will use some, of course, substitutes, but the general idea stays as it is and as it was. Before I jump in, let me briefly introduce myself. So my name is Daniel. I will not say my last name. It's really hard to pronounce, so let's avoid it. I'm working as a software developer in a Predica Group company. I was also awarded with Microsoft MVP title. I'm really passionate about Microsoft technologies. I encourage you to visit my technical blog, techmindfactory.com. If you have any further questions or you would like to ask about something or just connect, you can find me either on Twitter or you can just send an invitation on LinkedIn, and I'm happy to connect. Okay, that's great. But this presentation is not about me. This presentation is about the project implementation we did together with my team. So let me start with the business case. As I mentioned at the beginning of my presentation, it's good to understand what is happening here, because I wanted to show you something that was a real world scenario. It's not only about code and implementation, but it's also about the cloud infrastructure, about Azure cloud services, about implementation, some good patterns, some hints that may be helpful for you when you will be implementing similar scenarios or other scenarios, but with similar Azure services. So in this specific scenario, we needed a solution to get insights related to call center talks. So you can try to imagine that many companies have call centers, and inside those call centers, there are consultants that can talk to other people. And there are many different forms of such conversations. So you can try to imagine that someone is typing in the chat window. Yes, so hello, I have a problem. What can I do for you, etc. You can call directly and talk with the consultant. And of course, I would say the most advanced scenario is where there is a camera device, like right now. I'm talking to a microphone, there is a camera, and I can also write something. So in this scenario, we will focus on the analyzing content connected and collected from the call center. So what are the challenges here? So in our case, we wanted to improve contact with our customers based on the analysis of recorded audio, video, and chat history. We wanted also to know what is the average time of the conversation with the customer in our call center. So in this case, when you try to imagine the conversation during the consultant and the customer, there can be many scenarios, like the customer can ask about similar topics. So probably you would like to know what are the most important or most commonly discussed topics in the call center. But on the other side, you would like to know how many customers are satisfied. And this was also a challenging part of this solution, because when you try to imagine a basic solution when you have a conversation with consultant, and after this conversation, there are many scenarios that someone will send you a survey link, yeah, and you are asked to fill out this survey and share your feedback. But the reality is that there are many few people that will fill out this survey in the end of the conversation. So one of the challenges was related to a scenario where we would like to collect this information about sentiment, about the feeling of the customer during the conversation and after analyzing the collected data. And of course, the most important topics to make sure that probably if there are so many questions from customers related with one specific topic, probably we should update some frequently asked questions page or something like this. So once we had this, once we defined the business case and some functional requirements, or I would say requirements in general, we decided to go through the Azure cloud and try to think which services we could use for this kind of scenario. And here is the list of Azure services. And of course, I also prepared the architecture diagram, which I will display. But first of all, I would like to briefly discuss different Azure services we decided to use in this solution. So of course, when it comes to different files and collecting those files, you have to provide some storage. And when it comes to the cost, the most cost-effective and secure way to keep files on Azure is the Azure storage account. In this case, blob storage. So we decided that it would be nice to have all those conversations collected in either PDF files. If this was a conversation on the chat, we just collected those conversations in a PDF files. On the other side, there were files like audio, so like a call with the consultant. So those were MP3 files, for instance. And on the other side, there were video conversations, and we also wanted to store them somewhere. The second thing is that we decided that probably in this case, when we have this constant collection of data and there are new files uploaded to the blob storage, it would be nice to leverage serverless services available in Azure to make it more, I would say, event-driven architecture. So when there is a new file, either this is a PDF or MP3 or MP4, we would like to react on this upload and take up some actions. So that's why we decided here to use Azure Functions, and in this case, Azure Durable Functions, which I will discuss in details in a minute on the architecture diagram. And of course, when it comes to analyzing different aspects of the content, we decided to use Azure Cognitive Services here. And for the text content, we decided to use Azure Cognitive Services Text Analytics API to extract sentiment data. So how much satisfied is the customer during the conversation. And also, we decided to extract some key phrases from the sentences using Text Analytics API to make sure that we also collecting information about different topics during this conversation. And on the other side, we decided to use Azure Video Indexer to analyze audio and video content. And in a minute, I will also discuss the video indexer in details, but you have to know that that's the best service to analyze audio or video files if you would like to extract sentiment, discover people on video, if you would like to discover the topics that were discussed, etc. And of course, to scan PDF files, so those text files, we decided to use Azure Cognitive Services computer vision to apply OCR scanning on those PDF files. So first we scan those files, and then we send the text to the text analytics API. And at the end, of course, there is a question, great. So we collected the data, we have information about this analysis, so where we are going to store it. And at first glance, you can think that maybe Azure SQL, SQL database, relational database. But we decided to use Cosmos DB here because we knew that the data model that we use can change. So and one day we can only get information about the sentiment. Other day we would like to extend the solution and get information about the popular topics. The next day probably we would like to add some other functionality and properties to model. So that's why we decided to use Azure Cosmos DB to have this flexible data structure. And of course, at the end, Power BI report to display the whole information. So it's really easy to connect from the Power BI tool to Azure Cosmos DB, prepare a great dashboard to visualize the data. So I will also show you how to do it. And at the end, we wanted, of course, to monitor this solution just to make sure that we will avoid issues, or if there are any issues, we would like to track them and solve them quickly. And also one more thing, that why we decided to use Azure Application Insights is the fact that we wanted to track the information about processing of some files, because maybe some files were too hard to analyze them. We also wanted to keep such information. And now when we talk about the solution architecture presented on this diagram, you can see that most of the services are PaaS services, so platform as a service available in the Azure cloud. And also we decided to use the serverless, so Azure Durable Functions in this case, which I mentioned before. And right now we can discuss the process and why we decided Azure Durable Functions here. So on the left side of the diagram, you can see that there is some file. It can be text file like PDF, it can be audio file, video file. Once the file is uploaded to Azure storage, then this middle Azure function is triggered. So every time new file is uploaded to Azure Blob Storage, we want to react and apply some logic. So that's why we decided to use Azure Function here. And the second reason why we did it, we wanted to be cost effective, because probably you can think that, great, we could use the API here and just pull the Azure storage just to see whether there are new files. But the better solution and more efficient is just to add Azure Function here and only trigger this Azure Function when a new file is uploaded. And once this Azure Function is triggered, then there is orchestration. So this is why we use Azure Durable Functions to make sure that, basing on the file type, whether it's a text file or audio or video file, we will trigger one of those functions here. So as you can see at the top, there is another Azure function, another durable Azure function that is responsible for getting the content from the PDF file, so scanning it using OCR provided by Computer Vision Service in Azure Cloud. And once the content is scanned, then the content can be uploaded to the Azure Cognitive Services Text Analytics API. And this Analytics API is responsible for analyzing content, extracting the sentiment data, extracting key phrases from the sentences. And once this data is returned from the cognitive services, we would like to pass it further. And of course, the same scenario is for the audio and video file type. So basing on the file type, if this is audio or video, we would like to upload this, pass the link to this file to video indexer in Azure. And the video indexer will be responsible for analyzing video content and returning the data that is relevant for us. So in this case, so as you can see, once we upload those files, once we have results, we can combine them and we can pass them to the Azure Cosmos DB. So when there is a text file, we are analyzing it with the Text Analytics API. If this is analyzing it with the video indexer. If we got the result, we are calling the final Azure function is responsible for storing this data in the Azure Cosmos DB. And of course, once we have this data in the Azure Cosmos DB, we are able to report. So at the end, it's really easy to connect to the Power BI from the Power BI to Azure Cosmos DB and set Cosmos DB as a source for this diagram. So this is the general solution architecture. And as you can see, we leverage all services available in the Azure cloud. And right now, I would like to spend a little time discussing some patterns and functionalities we also focus on. So as I mentioned, we use Azure durable functions here, and in this case, fan out, fan in pattern available in the Azure Functions. And this pattern is related with some processing. So once we have this file uploaded on the blob storage in Azure, then the function F1 is triggered. And what we can do, the orchestration starts. So probably you would like to send the file for the analysis and control the state. And once there is a response from the service, we would like to store this information in the Cosmos DB. So what we wanted to do here, we wanted to make sure that once the function will call the external service, we will for sure get the result for this specific file. So in this case, you can see that we can trigger different functions from this orchestrator, but at the end, every result that was produced by this function F2 or functions F2, let's call them like this, the result will be aggregated in the function number 3, and then this function is responsible for storing this data in the Azure Cosmos DB. So that's why we used Azure durable functions here to just make it orchestrated, and at the end, the data will be combined and stored in the Azure Cosmos DB. And when it comes to the audio and video analysis, this was also an interesting project because we decided to use Azure Video Indexer. And I have to really admit that I heard about Azure Video Indexer before this project. And I was aware that it provides some capabilities like analyzing audio or video files, but I was not aware that it provides a lot of different, I would say, functionalities to analyze audio and video content. So as you can see, there is this audio analysis and vision analysis. So for the video files, and we can see here that we can detect language from the audio and video files. We can discover emotions. We can discover sentiment analysis. So whether the customer is satisfied or not. We can apply OCR scanning. We can apply face detection. We can detect keywords from different phrases. So a lot of different functionalities. So at the end, you can try to imagine that when talking about this service, it's very flexible. So in the future, if the customer will decide that he or she would like to also discover who is in the video, or for instance, in which language this video is and how to, for instance, translate it, this will be also possible with Azure Video Indexer in this case. And of course, when it comes to the Azure Cognitive Services, as I mentioned before, we mostly concentrated on the text analytics, just to make sure that in this case, we can just upload the text, analyze this text, get the sentiment, get information about the key phrases used here. And also, besides using text analytics, we also tested computer vision with OCR scanning here in this case. So it was really exciting to see that when we uploaded the file, there was information about the content, information about sentiment, a lot of different details. Yeah, so that was a theoretical introduction. So I don't want to talk only about PowerPoint slides. So I prepared some code to discuss, but of course I just wanted to make this introduction for you to understand the process, the business case, the solution architecture, and here we can move to the Visual Studio, and I will discuss what is happening in the source code. Yeah, so let me quickly close this one. So as I mentioned, just one more thing. This source code is available on my GitHub. You can find it. The link was provided and will be provided, no worries, in the Microsoft Azure AI. And here you will find out the solution architecture diagram, information about the components, about the flow, Power BI, sample Power BI diagram. So here there is not only the source code, but also you will find out that there is a sample data folder. And inside this folder, you can find sample files just to use some PDF file or MP4 file to play with. So I wanted to make sure that everyone will be able to use this solution. So before we jump into the Visual Studio, one more thing, in the Azure portal, you can see that here I have this resource group called RG Azure AI. And inside this resource group, there are those services I mentioned you during the presentation when talking about the solution architecture. So you will notice here that I have application insights for monitoring the solution. I have cognitive services for analyzing the text. I have cognitive services for applying OCR scanning. There is also Cosmos DB for storing the data. There are Azure Functions, Azure Durable Functions in this case, to process, orchestrate the whole flow. And you will also notice Azure Blob Storage for storing those different kind of files. And also there is a video indexer with Azure Media Services. So it's very important also to mention that video indexer requires you to create Azure Media Services instance in the Azure portal where you have your Azure subscription. And this is a sample. This is a sample video I have in the video indexer just to present before we move forward with the source code. If I open this video, I hope this will work. You can see that there is the video that was uploaded here. And of course, this is a sample data. It's not a real scenario. Let me pause this video to make sure that this will not. Yeah. A sample conversation in the call center, and on the right side you can see different insights that were extracted from this video by video indexer. So as I mentioned, you can identify people in a videos. This is not this scenario, but you can extract the topics that were discussed during the conversation. There are also labels, so you can get a description what is happening on this video. It's also it can be also interesting. There are named entities. It can be like city or a place or something else. And there is also information about emotions here, so you can see that we can analyze emotions in a specific video and specific frames here. And there are scenes, yeah, so we can also divide this video into scenes, and we can analyze those specific scenes. So it's really powerful. This is just an example, but I really encourage you, if you have enough time, you can play with video indexer and cognitive services. And when we go to the Visual Studio, this is the structure of the project, and this is the implementation. And here I would like to talk about patterns. Here I would like to talk about implementation details, and here I would like to talk about some challenges. So let me start from the structure. As you can see on the right side, there is this main project called Azure AI Call Center Talks Analysis Function Apps. And inside this project, we have Azure Functions and some other services related with those functions. Before I move to the Functions App project, let me briefly discuss the structure of this solution. In the infrastructure project, we have all the services, so the classes implemented to communicate with those external Azure services here. So we also wanted to keep this structure clean. So we didn't want to keep all the services, all the classes in a one project, because there can be a mess. So that's why we decided to create a dedicated project called infrastructure. And of course, there is also a core project, and inside this core project, we have some models like input file data or file analysis result. You can see here the list with sentiment values. And of course, there is one service just for verifying the extension of the file, just to make it simple. As you can see, as I mentioned, I slightly modified the implementation, of course, but this is how it was done more or less. So let me open the Azure Functions project here. And in the Azure Functions project, what we did here from the developer perspective, we used dependency injection. So here in the startup class, you will find out that there is a registration for all those different components used in the application to communicate with different Azure services. So you can see that we are loading configuration, we are adding file format validation service, we are adding component related to Azure storage just to get information about the files. We are adding services related to Azure Cosmos DB communication, and file processing services. Those ones are used to connect either to text analytics API or video indexer. And of course, I will discuss them configuration part related with the config. So we also added this here. So as I mentioned, dependency injection is used here. And if you if you open the core dependency injection folder, you will find out that here, let me open the first one, storage service collection extensions here. What we did, we registered the blob service client. This is the class available in the new Azure Storage SDK for .NET. So here you can see that we register blob service client as singleton, and we decided to create this storage service class, which is responsible for managing files on a blob storage, and also for generating the shared access signature, so this SAS token for those files. And let me briefly describe what's happening here in this class, just to avoid confusion. So this class implements iStorage service interface, and as you can see, there are different methods. There is a method for downloading the blob, if exists on Azure Blob Storage, uploading blob, deleting the blob, getting the blob URL, so we can get a pointer to a specific file that was stored in the Azure Blob Storage. And of course, we can generate this SAS token. And the reason why we had to add it here is the fact that the links to those files stored on the Azure Blob Storage are private. So you do not have external access to those files. So what we wanted to do, we wanted to provide a temporary access for those Azure Cloud services, like for the video indexer and for the text analytics API. So we decided to generate those temporary shared access signatures, add them to the URL link, and then the service was available to connect, get the blob content, and after, let's say, some minutes, it's configurable. After a few minutes, we were able to, I would say, depreciate this SAS token. So of course here, as I mentioned, everything is implemented in this storage service class. So if you go to the GitHub, you can notice that there are different methods. There is a logging added with application insights, just to make sure that we know what's happening if the file was not uploaded correctly or something like this. You will find out this generate SAS token method here also. The other important aspect of this project, when it comes to the usage of those services, because I will not go through each class responsible for dependency injection. I encourage you to go through the source code on GitHub. But of course, every service was registered using a separate extensions here. So the same is for the Cosmos DB. You can see that there is data service collection extensions. We are creating Cosmos client. We getting access to the database. We are setting containers, so where this data should be stored. And also we are registering this instance as a singleton because it's the best practice recommended from Azure SDK team to do it. So here, let me close it for a minute and let me open those functions that we have here and those durable functions I mentioned. As you can see in the functions folder, there are different functions related to our solution. So let me open the first one, media file trigger. As you can see here, this media file trigger function is responsible for reacting to all new files that were uploaded to the Azure Blob Storage. That is why you will see the blob trigger attribute here. So this function will be run every time new file is uploaded to the blob storage. And what is happening below in this function, let me enlarge this code. Of course, we added logging here just to make sure that we know that new file was uploaded to the blob storage. And here we are using this iDurable orchestration client interface, but of course this is the instance, to start a new instance of the orchestrator. So the function that will be responsible for further processing, I would say, to make it easy. So to getting the file, verifying extension, and also sending this information to the cognitive services, waiting for the information back, and then uploading this to the Azure Cosmos DB. So once the new instance is started, we of course added a logging for this information. So we can see that we are starting new file analysis orchestrator. And this is this class. And also please note, let me show you briefly that in this static class, we have the names of different Azure functions used in our solution. So in this case, when I go to the file analysis orchestrator, you can see that this is this function analysis orchestrator. So once the new file is uploaded, this orchestrator is created. And in the run orchestrator async, you can see that what is happening here, we're getting the file location. And what we are doing here, we're verifying the file content. So we have to get the file content, and as I mentioned before, just to make it simple, I just changed this code. So here you can see that we are just checking whether it's PDF, MP4, or MP3. And once we have this content, we can decide which Azure function we will call to manage the process of calling cognitive services and getting back this response. So let me briefly discuss what's happening here. Once the file location is passed to this file format validation service, and we have information about the file format, we creating this input file data. And this input file data has two properties. The first property is file content type, so MP3, PDF, or MP4. And the second attribute is the file path. So we providing a file path to the content that is stored on the Azure Blob Storage. So this is the URI to the resource, to the file stored in the Azure Blob Storage. And then, basing on the file format that was provided, we will call either idle text file analyzer function, or we will call audio and video file analyzer function. So as you can see, basing on the file content, we will use this context.call activity async method. And here, as you can see, we are passing the name of the function. So in this case, function text file analyzer, and this input file data parameter. And the same is done for the MP3 and MP4 files. But in this case, the difference is that you will notice that we are calling this function audio video file analyzer with the input file data here. And now, after we have analysis result from those functions, and I will discuss them in details in a minute. Once we have analysis result in both scenarios, we can call the last function, so analysis result aggregator function, that is responsible for storing this analysis result in the Azure Cosmos DB. So we will see here that there is this function analysis result aggregator, and we are passing this analysis result that was returned from one of those functions that were used to call either Text Analytics API or Azure Video Indexer. And of course, if the file format is unsupported, we would like to log this information and nothing will happen in the end. No orchestration will be proceeded. So now, if I open this, let me start with the text file analyzer. So once we have like a PDF file uploaded, this text analyzer function will be called. And you can see here that again, dependency injection is used. So we are using interfaces here to make it easy to test those functions and write unit tests. This interface derives from iFile processing service. And you can see here that there is one method, there is analyze file content async method. We have this input file data parameter, as I mentioned, two properties. So the content type and also the link to the file stored on the blob storage, and this file analysis result, which is in this case, to make it simple, a sentiment values list with unique ID. And this information will be stored in the Azure Cosmos DB. When this text file async method, we will notice that here this function is triggered with this input data that we created this parameter in a previous function I showed you. So in this file analysis orchestrator, and once we have this input file data, what we can do, we can call text file processing service analyze file content async method with this input data. And what is happening here underneath, let me show you this one. As you can see, there is a method that will call, in this case, either video indexer or text analytics API. In this case, we are talking about the text files. So let me focus on this class, so text file processing service. And as you can see here, if I pass this input file data, here we can verify again whether it's PDF file. If this is PDF file, what we are doing here, we're generating this shared access signature I mentioned you to make sure that Text Analytics API will be able to access the URI of the file that is stored on the blob storage. And once we have this file, what we can do, we can first of all use the computer vision API to apply OCR scanning and get the text. So as you can see here, text from the input document parameter is provided here. And this is the result returned by the computer vision service. And then what we want to do, we want to call Text Analytics API with this file, with this string content that we retrieved from the OCR analysis. And we would like to get this sentiment analysis in this case. So you can see here that, again, to make it simple, you can see that it's modified when there is a response. We're getting the value of this response. We're creating this file analysis result instance. And then we are adding the values of the sentiment to this list. And we returning this file analysis result object that will be passed to this third function responsible for storing data in the Azure Cosmos DB. And if I open let me open audio video file analyzer, you will notice that it's quite the same function and quite the same logic. But in this case here, we are using audio video file processing service implementation. And here we are using this audio video processing service to get the content. So if I open this once again here, you will notice that this method is responsible for calling Azure Video Indexer. So in this case, we have to generate some API key headers, access tokens. But to make it clear, what is happening here, we have to, again, generate a SAS token for this file to make sure that Video Indexer will be able to access the file and read it and extract the content from it. Here we have to pass some parameters for Video Indexer, like access token or the name of the new video file, the information about the privacy, either this is private content or not, and some other parameters. One of them is very important, video URL. So this video URL parameter, as you can see, this will be the URL that is pointing to a file hosted on the stored on the Azure Blob Storage. And here we are using a standard HTTP calls. So HTTP client here is used available in C#. We are posting a sync, this whole request, and then we are waiting for the information about the upload. So we would like to know whether this file was uploaded correctly or not. And there are two parts. So once we upload this video, we will get the unique identifier, but then Video Indexer will start file analysis. So there is no immediate response from the Azure Video Indexer. So you have to wait a few seconds or sometimes minutes to get the result. So as you can see here, what we have here, we can get information about the analyzed, let me show you, it's here, yeah. We can call another endpoint of the Video Indexer, and we would like to check whether the information about the video is ready. So as you can see here, there is this task delay used. So we are stopping this process for 10 seconds because we don't want to call every second, call the Azure Video Indexer. So that's why there is this simple approach here, this while true loop, and we are calling the Video Indexer. And once we have this information collected, we can just deserialize this information, and again, we can store it under audio video analysis result, which is this object. There are some different properties. Again, I encourage you to visit my GitHub to see those different properties. But in general, this is information that is returned by the Video Indexer. And what we can do, once we have this audio video analysis result, you can see that one of the properties is called Summarize Insights. And under this Summarize Insights, there is information about the sentiment. So again, we can extract the sentiment information from the data that is returned from the Azure Video Indexer. And once we have it, again, we have this file object, sentiment values list. We are adding those values, and we can return this file analysis result. And then once we have this analysis result, so getting back to our orchestrator available in Azure Durable Functions, you can see that here, again, this is for the text files, this is for the audio video files. But let's say that we used Video Indexer in this case. So once we have this analysis result returned from the function I already discussed, what we can do, and we have to do, we have to call this function called function analysis result aggregator. And let me show you briefly what is happening here in this function. So once we have this analysis result, we are happy that there is a data that we can store in the Azure Cosmos DB. Here, there is analysis result aggregator class. Again, here we have this dependency injection usage. So we see that there is iData service used, and the instance of this service will be injected during the runtime. And this iData service here got some methods, as you can see: add async, get async, update async, delete async, and get all async. This interface was provided to easily exchange data with the Azure Cosmos DB. So you can see here that we are using this data service. And once the analysis result is not empty, we can call data service.addAsync, we can pass this analysis result, and this analysis result will be stored in the Azure Cosmos DB. And again, if there is an information that analysis result is empty, we would like to log this information. And of course, when it comes to the different libraries we used here, if I right-click on the infrastructure project and go to the Manage NuGet Packages, you will realize that here, most of the work could be done using Azure SDK for .NET C#. So you can see that there is this Azure AI Text Analytics library used, and we use this library to call Text Analytics API service. There is Azure Cosmos. So this is a new library. It's still in preview, but this is the new library for managing Cosmos DB resources from the C# code. And we use this Azure Storage Blobs to manage files on the blob storage. So as I mentioned before, we use this library to generate those shared access signatures for files to make them available for Azure Cognitive Services. And of course, computer vision for applying the OCR scanning here. So yeah, so this is really important to mention that some of those services already have libraries. For the video indexer, we used direct HTTP calls because it was much easier to do it. And at the end, what I can say here is the fact that let me show you that here. Yeah. So what is important to mention that once the data is sent to the Azure Cosmos DB, so if we go to the Azure portal and open this Azure Cosmos DB Data Explorer, we will notice that there is a container with container, and here you can see that we have those sentiment values. So for one video there is a neutral, positive, for other is mixed, as you can see. So different insights. And once again, the decision behind the Cosmos DB was that we can easily extend the schema here. So we can add, if we decide in the future that we would like to extend the solution with some other capabilities, we will be able to easily update the model too. Yeah, so at the end, just to clarify, as you can see, data is stored in Azure Cosmos DB. At the end, and I know it's not beautiful, and I realize that, and I'm aware of that. I'm a developer, so I created this simple Power BI diagram here just to show you that we can easily connect to the Azure Cosmos DB. But believe me that in a real scenario, this diagram was, this dashboard, I would say, was it was beautiful. But in this case, I know it's basic. But this is just to show you how easily at the end we can access this data. So once you open the Power BI application, this is then the standard application that is available even in the Windows Store. What you can do here, there is a Get Data section, and there are common data sources. And what you can do here, you can click More section, and after some time, you will notice that there are different data sources for the Power BI, and one of those sources is Azure Cosmos DB here. So again, it was really easy for the people responsible for creating those dashboards to just generate beautiful dashboards basing on the data that we stored in the Azure Cosmos DB. So as you can see, we can select Azure Cosmos DB as data source. We can connect. Of course, we have to specify connection string. We have to provide the name of the database, container name, etc. But at the end, as you can see here, we have this possibility to create different queries here, apply different modifications, and we can display information, for instance, how many positive emotions were during those conversations, or how many customers indicated, I would say, mixed feelings during the conversation with the consultant. So this is really helpful. And also, in this real diagram, there were also topics included. that were mentioned during this conversation. So there was like I would say a great visualization that showed different, I would say, like bubbles, and inside those bubbles there were information about different topics. So it's really easy here. Yeah, so let me get back to the presentation. So I see that we have 4 minutes until the session will end. And that's it from my side. I'm really happy that I was able to pass this portion of information. And if you have any questions you would like to ask about something, I'm more than happy.